Okay, hello everyone, and today we will discuss and represent you the project of fake news detection. Let's start. And let's start with a problem statement. What fake news is? It's like the set of texts, right? And we have a sequence of tokens, which is our text. And for each text, we need to assign a label indicating whether it is fake or legit, as it presented here on the slide, with 0 or 1s. And here we represent the steps that we will go through. It's firstly, we will discuss our methodology and data sets and data processing, which we are using here, and our experiments, and of course, the results that we obtain from them. And we will end with conclusion, as usual. Okay, let's start. Our work is inspired by the article in which there was an idea to use language models transformers for such task, and then also we did the following preprocessing. We used CLC tokens and special SEP tokens between the first and second sentences. And by the way, in our implementation, we use the CLC token embedding from the final layer of output for all models except Elmo. And for this transformer, we use meme pooling over output embeddings. Now let's introduce you the list of our models itself. Here you can see them, and we evaluate a variety of language models, and most of them are available, and most of the pre-trained weights were provided by the Hugging Face Transformers library, and we used this library and of course PyTorch library to train the model, and actually all models were taken from there except Elmo, because this model was implemented with the help of Allen NLP. I mean, this model, Elmo, was implemented with Allen NLP library, and in addition to this, models evaluated in the original articles, we have tested another models which was designed to have longer sequences of tokens as input, which is a longer format. Okay, let's proceed. Now let's see what datasets we used. In this project, we used 5 datasets, which are represented here. And the first 3 ones are small datasets, and the other 2 datasets are huge enough. And you can see how much fake and how much just news and articles contains each dataset. Let's proceed. Then we used, since in our datasets the texts were like too long. For instance, the average number of sentences in each text was 20,000, and when we tried to train all of them, of course, yeah, we had the error of CUDA memory couldn't allocate all of them. Therefore, at first try, we decided to cut we decided to cut to 500 symbols of each sample text and use them. However, it's of course not a very great idea, and we had overfitting. Therefore, we decided to use another approach, many splits, and instead of only taking 500 symbols, we can split each article on pieces and get several samples corresponding to one piece of news. In this case, we get the larger dataset, more stable to overfitting. To get the metric values during the test phase, we used the majority vote strategy. If majority of fragments of sample text were classified as legit, we treated this article as legit and pick other ways. Here are the metrics that we use. It's FID score, precision, and recall score. Okay, let's now proceed. Here we used the 500 symbols method where, as I told you, we took only 500 symbols of each sample text. Yeah, and we see the results of scores of each model here. And here the large data sets that I already mentioned to you. Okay, since as I told you that at first try we used 500 symbols, we can see that on the third and fourth epoch we have overfitting. However, when we use many splits, so we can see that we solve the problem with overfitting, and there is no overfitting in many splits approach. Then we use the next approach when we decided to train on one data set and validate on another data set, which is different to the previous, and which we called cross tests. And here we train on a celebrity data set and we validate on a recovery data set. And the results and scores can be seen here. Then, as we can see, results relatively similar. Keeping in mind that many splits helps to reduce overfitting and it's faster to train. We can conclude that this method is more preferable. However, the scores are a bit approximately the same. Okay. Then since transformer-based models are unable to process long sequences due to their self-attention operation, which scales quadratically with the sequence length. To address this limitation, we use the long former with an attention mechanism that scales linearly with sequence length, making it easy to process documents of like thousands of tokens or even longer. So here you can see the results of the long transformer that we used for handling long sentences. And the scores can be seen here. Then as we told previously, we used Elmo model, and the approach was written with the help of Alien NLP library. And while conducting experiments with this model, it was discovered that creating the vocabulary straight from the training data doesn't give the good quality of classification. FID score was about 50%. However, with BERT vocabulary, the result became significantly better. And we can see it here. And also we decided to look at the attention layer and visualize it. Since almost all of the models in our list use attention mechanism, that is why we decided to visualize attention layers in order to get maybe some more understanding what words are important for models to make a decision. We've chosen BERT model for our test as the most famous model, and the figures we obtained showed that the most informative is the most information contains CLC and STEP tokens, as we can see, and separation tokens. That's why taking the CLC token for classification is a good choice. This experiment illustrates the choice of the authors of the referenced articles. Unfortunately, no more like interesting dependencies we didn't found, and you can see the visualization of layers here, and almost all of them like almost all of them show the same picture. So as a result of our work, we can spotlight the following results. Transformer showed good results for fake news classification, and then we compared two approaches of 500 symbols and many splits, and the second one performed better because it avoids overfitting. And as we have already mentioned, Elmo performs surprisingly cool with F1 score, which equal to 1. That's why we propose Elmo is very, very powerful. And as a future work, we wanted to highlight the following things. Firstly, it tests on larger batch sizes, use better hardware for large transformers, and test other approaches for data preprocessing. Okay, thank you for attention. This is our team. Goodbye.